On today's episode, we're doing this. Rational expressions. Problems that look like this, problems that look like this, and problems that look like this. So please stay tuned. If this is your first time here, please make sure to subscribe and click the bell icon to get all notifications when I release a new video. Make sure you also comment with questions, opinions, answers. All this helps me make better videos for you. Now, rational expressions. When going through most college syllabuses and textbooks, some of the hardest problems surround the topic of fact. One such topic is rational expression. Last week we went over some methods of factoring. Rational expressions takes this to another level. We essentially have to factor numerators and denominators, since rational expressions are simply another word for algebraic expressions in fraction format. Factoring will be at the core of simplifying any rational expression. For our intents and purposes, we won't bother much on defining rational expressions beyond that, and instead we'll focus more on the questions and learning by example. However, since we're going to learn through examples, it's pretty important that we first define rules. The rules governing rational expressions are similar, if not the same, as the rules that govern factoring that we did last week. Factoring of quadratic or polynomial expressions. Rule 1. The first thing you need to do is to combine like terms. Before you can even proceed, you have to combine all the terms that look alike. Get it into a more proper form. Similar to step 1 of last week, our form would first be to combine like terms. Rule 2. Factor each polynomial expression. Recall from last week that factoring is the art of breaking things down. Rational expressions contain two algebraic factorable expressions, one in the numerator, one in the denominator. Factoring both is key to simplification of rational expressions. Step 3. Canceling any common fact in both the numerator and denominator. Remember what our goal is. Our goal is to be able to reduce, factor, break down. We want to be able to simplify a rational expression. In order for us to be able to do that, we have to be able to cancel out when necessary. So now that we have our rules down, let's proceed with 3 examples so we can get our feet wet and understand the topic more thoroughly. Again, at any time, if I am going too fast, because the style of my videos are fast in order to keep you guys engaged, but at any time I'm moving too fast, please stop, slow down, and rewind my video to any part you've missed. Do not be afraid to pause and take time to complete an exercise that we're doing. Take time to understand what we're doing. On your screen is a scale. This scale will tell you the difficulty of the problems that appear before you in relation to college freshmen's understanding of the topic. That number of difficulty will go from 1 to 5, 1 being the easiest and 5 being the hardest. In this lesson, I'll start you off with a level 3 problem. This level 3 problem will just help you see what I was talking about in the steps beforehand. Let's look at a problem. Level 3. V squared minus 7v minus 30 over v squared minus 5v minus 24. When you look at this problem, the first thing we have to do from our steps is combine like terms. But no, there's no like terms to combine in the numerator or separately in the denominator. It's in a good form. Step 2, factor. It's critically important to understand what type of factors we need. In this case, we're given for a c value a negative 30. So we list all our factors like so. Then we need the combinations of factors that can multiply up to our c values and add up to our b value. In this case, we need the combinations of negative 10 and positive 3. Negative 10 plus 3 adds up to negative 7, and negative 10 minus 3 multiplies to negative 30. So our top values are set. We have it as v minus 10 times v plus 3. We have to repeat for the denominator. Same deal. The only combinations that will add to a negative 5 and multiply up to a negative 24 are v minus 8 times v plus 3. If you look at our rules for simplifying rational expressions, we can go on to step 3. In step 3, it shows us that we have to be able to cancel out all the common terms in both the numerator and the denominator. The common term in our numerator and denominator are v plus 3 up top and v plus 3 on the bottom. Those two values get canceled, and we're left with an expression of v minus 10 over v minus 8, our answer. On to the second question. The second question reads v squared minus 3v minus 40 over v squared minus 11v plus 24. Following our steps, step 1 says for us to combine like terms. In this case, we don't need that step. We're good here. Step 2 says for us to factor. So when we factor both the numerator and the denominator, we're looking for terms in the factors of our c values. So we're looking for terms in the factors of our negative 40 and also the positive 24. So those factors are listed like so. From these factors, we need to be able to find the combination that when we add it together, we get back negative 3v, and when we multiply it, we get back negative 40. The only combination that can do that is 8 and 5. Again, not just 8 and 5, negative 8 and positive 5. When you add a negative 8 plus 5, you get negative 3. When you multiply a negative 8 times 5, you get negative 40. That's our numerator. So our numerator has v minus 8 times v plus 5. In our denominator, we're looking for the factors of positive 24. They're listed like so. Once again, we need two factors that will add up to negative 11. In this case, it's slightly easier because the value that's in front of the c value is a plus, and the value that's in front of the b value is a minus. So that means that both terms have to be the same sign. In this case, both terms have to be minus. So the only two terms that will add up to negative 11 are negative 8 and minus 3, leaving us with a rational expression of v minus 8 times v plus 5 over v minus 8 times v minus 3. The common terms are v minus 8. We cancel them out in our numerator and our denominator, leaving us with a final answer of v plus 5 over v minus 3. Second problem done. Problem number 3. It reads this: x to the third minus x squared minus 42x over 2x squared minus 20x plus 42. Our numerator will need a form of factoring we hadn't discussed in detail, but we did go over a little bit last time, known as GCF. We need to be able to find the greatest common factor, the greatest number that can go into all three of our terms. Boom, boom, boom. The terms are x to the third, negative x squared, minus 42x. So the only term or variable that we see that can go into that expression is the letter x. So x is our greatest common factor. Yanking x out of the parentheses, we see an expression that looks like this: x parentheses x squared minus x minus 42. Then we solve like above. Getting the factors of negative 42, we'll be left with two factored forms: x minus 7 and x plus 6. That's in our numerator. For our denominator, it's very similar to the first problem we did in the last episode. Our a value is greater than 1. In the steps from the last episode, we said if our a value was greater than 1, we had to guess and test. Ignore the middle. We needed to focus on the factors of 2 and the factors of 42. In this case, the factors of 2 are 1 and 2. Those numbers will go in the beginning of both our parentheses: 2, x, and x. In the second half of our parentheses, we need the factors of 42. To make our lives a little bit easier, we can also use GCF in this denominator. The greatest common factor for all the terms in the denominator, if we're looking at it, has to be the number 2. 2 can go into 20, it can also go into 42. Pulling 2 out, we're left with an expression that's easier for us to factor because we don't have an a value greater than 1. We can do this in some cases. In the cases where the a value can be factored into all the rest of the values, i.e. b and c, you can easily do this. And that's what I'm going to do here. I pull my 2 out. After I pull my 2 out, I'm left with an expression of x squared minus 10x plus 21. Then I factor like I factored above. I need to find my factors of 21. The factors of 21 are 7 and 3. So our factors, when we factor it out, will be x2, big parentheses, x minus 7 x plus 3. We can cancel out our x minus 7s, leaving us with an expression of x parentheses x plus 6 over 2 parentheses x minus 3. I mentioned the last step just in passing. That was step 3. We needed to cancel out the common terms. In this case, our common terms were x minus 7. You'll find with problems like this, they have a lot of common terms. Finding common terms are key in factoring rational expressions. So that was problem 3. But let's stop now and pick this back up next week, where we'll do more lessons in college algebra. Again, guys, please make sure to like, comment, and subscribe. Subscribing, commenting, and liking help me make better videos for you. I'm AKG, and I'll see you next week for another lesson.